Welcome back, Balancing Writing Nuclear Equations. Okay, so these are different kinds of particles or emissions or energies, however you want to look at it. We got alpha, beta. Notice that alpha has two different symbols you could use, but same mass number, atomic number. So we can use He, helium, or an alpha symbol, beta. Gamma emission, positron emission, electron capture, and neutron. All right, and so we're going to go through some examples of how to do this. So first we have this question number 1. It says curium-251 breaks down to form an alpha particle, should say an alpha particle, and another element. Okay, so we're going to go through that and I'll teach you how to do this. So you are going to have to remember that this number after the dash, the number after the dash, in an element name like this is going to be the mass number. Okay, so you are going to first figure out what the atomic number of curium is. Go to your periodic table and find curium. You're just going to have to search for it. You can kind of look in the 250s on the bottom number on the periodic table. That might get you into the right area. You hopefully will have found that it has an atomic number of 96. So we're going to write the symbol. Well, once I get my pen working. Cm 96. 251. Mass number goes on top, atomic number goes on the bottom. It says breaks down. Breaks down tells us in chemistry to draw an arrow. To form, it's going to form something, an alpha. So you'll have to look back to your list of particles and energies. An alpha particle and another element. So we're going to figure out what this other element is. So what we're going to do is we're going to think about the arrow as an equal sign. And we're going to sort of divide it right here. We're going to take the sum of all the numbers on the left, on the top, and the sum of all the numbers of the right on the top. So on this side, we only have this, so it's 251. And we got 96. Here we have 4, and we have 2 so far. Now, we need to do something to make them balance. Because in chemistry, your stuff has to balance on every side of the arrow. So we have 251 and 4. We need to be thinking about what number do we need that gets us to 251, because we can't go down to 4. So we're going to do 247. 247 plus 4, and then what number gets me to 96? If I start at 2 is 94. So we're going to figure out who this element is by its atomic number. So looking for atomic number 94, we get Pu. And then just to double check our math, I want to show you this piece. So we would say 4 plus 247 is 251, and 94 plus 2 is 96. So now we know that 251. So now we know that these numbers are equal and these numbers are equal, so we set this up. Okay, next example. Beta emission by mercury 201. Okay, so we know this is mercury 201. We know that the mass number is 201. Number after the dash is the mass. We know it's mercury. So you're going to look up the symbol and look up the atomic number. You should see that mercury is element 80, atomic number of 80. Okay, and it says beta emission. Now, why didn't we put beta first? Because if I'm emitting something, it's going to be after the fact, right? So it's emitted or given off. So beta is -1 beta plus something. Back to thinking about the math now. The top is 201, because 201 is the only thing over here, 80. And this is 0 and -1. Okay. So now we're going to go through and say, what do I need to do to add 0 to get to 201? I need a 201 on top, because 201 plus 0 gets me to the 201. And what plus -1 gets me to 80? I got to do 81, because 81 plus a -1 gets me to 80. I'm going to look up and see who element 81 is. The symbol for element 81 is TL. So now I'm just going to double check my math to make sure everything looks okay. So 0 plus, okay, so this changes from 0 to 201. And 80 plus -1, 81 plus -1 is 80. So now we're done with this problem. Okay, next example. This time we're going to do a positron emission. So SM, samarium 152. So SM 152 goes on top. And I'm going to figure out what the atomic number is. Find samarium on my periodic table at 62. It says positron emission. So the positron has to be emitted or given off afterwards. So we're going to have 0 plus 1 beta. You don't have to write the +1. I do that just to enforce on my brain that I know it's positive. I'm going to think about what my totals are on each side of the arrow. So I split it. I have 152 and 62, and I have 0 and 1. So now I'm going to be thinking about what do I need to do to get both sides to be the same on top and both sides to be the same on the bottom. So 152, because 152 plus 0 gets me to 152, and 61, because 61 plus 1 gets me to 62. And I find out that element for 61 is PM. And now I've completed that problem. Again, I would just like to suggest that you go back in at the bottom, at the end, pardon me, and make sure, okay, that is that. That's 152. This is sort of your check. And this is 62, so I know those are good. All right, next example. So we are going to go to tungsten 185, and I took tungsten is an atomic number of 74 because I looked it up on the periodic table. It says alpha emission, so it means it emits, gives off an alpha. We know alpha is 42He plus something. We don't know what that something is, so we're gonna think about that like this, and we're gonna say 185. And 74, and then this is 4 and 2. Okay, so we're thinking about what do I need to get to do 185? I need 181. 181 plus 4 gets me 185, and what plus 2 gets me to 74? 72. And I look up element 72, and I see it's HF, hafnium. And then I'm going to double check my math here. So I take 4 plus 181, I get 185. And 72 plus 2 gets me to 74. I know I'm done. Example 5. Osmium 192 breaks down to form a beta particle in another element. So just a little bit of a different way of writing it. So osmium is OS 192. And I look up its atomic number to be 76. It says breaks down. Remember, breaks down tells us to draw an arrow. A beta, which is 0, -1, beta symbol plus something. Okay, we don't know what that something is. So we're going to break this down like we always have at the arrow. We're going to think about what are my current totals on each side of the arrow. So I need to get to 192. So I'm going to do 192. Let me go ahead and get that to a thinner pen. My handwriting is bad enough without the thickness. Okay, so I have 0, so 192, and I have a -1, so what plus -1 gets me to 76, 77, and that's IR. So double checking my math. We get 0 plus 192 on this side goes to 192, 77 plus -1, it gets me to 76, and we know this is done correctly because our top number totals equal each other on the left and the right, and our bottom number totals equal each other on the left and the right. Okay, we got radium 227. So we're going to take radium 227. We're going to look up radium, and we're going to see radium's atomic number. Okay, here we go. So we got Ra. I guess we'll switch colors. 227 and is 88. It says breaks down, tells us to draw an arrow of francium. So that's going to be 227. 227. And look it up on the periodic table, 87 plus, we don't know what, we're going to figure out what that is. Change colors. Okay, split it. And we know this side totals to 227, this side totals to 88 because that's all that's over there. On this side we have 227 and this side we have 87. So we need to figure out what we need to get there. So what plus 227 gets me to 227? 0. What plus 87 gets me to 88? 1. So now I have to figure out, is this hydrogen or is it one of my particles? So if there's a 1 or a lower, so a 1, a 0, or a negative, then we know we're looking towards our particles. A 1 could be hydrogen, but it'd have to have something on top to be hydrogen. Okay, so we're going to go back to our particles because I have a 0. Basically, if you have a 0 involved, let's go back and look at that. So if you have a 0 involved, you know it's one of these 5. Okay, and if it has a 4,2He, you know it's alpha. That's kind of how you got to think about it. So 0 on bottom makes it a neutron, 1 on top. So let's go back to that. Okay, so then we know this is a neutron. Let's double check our math. So we've got 227, 227 plus 0 is 227, 87 plus 1 is 88. So the top numbers are equal, bottoms are equal. We are good to go. Okay, this is a little bit different. This one here, I don't have words, I just have the stuff already built. I find it useful to rewrite it. It's up to you, but I think you will also possibly find that more useful if you rewrite it. Now notice there's a 2 here. We haven't had that yet. This 2 basically is just like in math class, meaning that there are 2 of these. It's counting them. So 2x's, right? Okay, so this is going to be 0, -1e plus 0, -1e plus we don't know. So this is our missing piece right here is what we're doing. Okay, so let's do the same thing we always done. Let's split it. And let's look at 251 and 97 and 0 and -2. Alrighty, so we're trying to figure out what's missing because I don't have equal numbers. So I have 0, but I got to get to 251. So we're going to have 251 on top because 251 plus 0 is 251. Remember, there's 2 of these because there's a 2 here in front. Okay, and then I have -1 and -1. I need to get to 97, so I need 99. Because 99 plus or minus 1 plus or minus 1 would get me to 97, so that's ES. So we're going to double check that math. And we're going to see that this does in fact go to 251 because 0 plus 0 plus 251 is 251, and -1 plus -1 plus 99 is 97. So we are done. We ended up producing an Einsteinium. Okay, looking at the next example, 8. Again, I like to rewrite these. I don't remember what color my pen is. Okay, so 15864 GD. Let's try that again. Yeah, that's yucky. Hold on. Let me clean that up. GD goes to 10N plus 15564 GD. Now you might be asking yourself, well, is this done? It could be, but we got to check the math. So let's split it and check it to see if it's balanced or equal. I've got 158 and 64. Over here I got 156 and 64. So it is not balanced. So I need to put in what's missing, just like we've been doing. All right, I know I have 155. I got to get up to 156. I'm sorry, I got 156. Apology, 156. I need to get to 158, so I need 2. But I have 64. And I need 64, so 0. So we have a 0 someplace, so we're going to look back at these items here, these particles and energies, and we're going to see which one is helpful to us. Okay, so I knew I had a 0 on the bottom, so it's either going to be a gamma or a neutron. But you might be saying, well, wait a minute, there's not a 2 on top of a neutron. But think about this, if I put a 2 here, we would have a 2 on top because we're going to distribute that through, right? So let's go back to that example and think about the fact that this probably doesn't look like this. It possibly could look like this because I still maintain my 0 on the bottom, my 0 on the bottom, but now I have 2 of these. So if I were to clean this, let me fix the math first. Let's make sure the math is good before I do that next piece. So now I take 155 plus 1 plus 1 plus 1, and I get to 158. This is the probably most difficult one of all these. 0 plus 64 plus 0 plus 0. So 0 plus 0 plus 64 plus 0 gets, okay, so that looks good. Now, you can clean this up and write this properly as such. And I don't really care which way you leave it. Unless I ask you specifically, you can leave it like it is up above. This would be 3 10Ns, 3 neutron particles, or 15564 GD. All right, so look this 3, remember, because there's 1 on the left side, excuse me, the right side of the arrow, there's 1, 2, 3 of these, because this is gone, remember, because we rewrote it. So there's 1, 2, 3 of these. That's what the 3 comes from here. Or you can leave it like this, I don't care. Now, you might be saying, well, wait a minute, I have the same element. Yes, but it's a different isotope. Remember, because this is 155, this is 158. These are different isotopes of GD. Okay, this comes from your homework. I just wanted to go over an example of the different types on your homework. They're a little different than this, but not really, just the way it's formatted. So some sentences and some done for you. So we're going to take and we're going to split at the arrow. And I'm going to make my pen less hard to read. So there's 10 on that side and 5 on this side. Remember, 9 plus 1 is 10, 4 plus 1 is 5. We have 4 on this side and 2 on this side. So I'm thinking about what plus 4 gets me to 10, a 6. What plus 2 gets me to 5, a 3. Now, I have no zeros, so it's going to be an element off the periodic table. And I look up element 3, and I see that it's lithium. Okay, next one, hydrogen 3. So H and this is going to be atomic number 1, mass number of 3, breaks down, that tells me to do my arrow, to form a beta particle, so 0, -1 beta, plus another element. We're going to figure out what that is. Okay, so we're going to say, we'll just switch colors for purposes of looking at this. We're going to think of our arrow as 3 and 1, and 0 and -1. Watch those negatives. They can be very tricky. They're not meant to be, but you got to think about your math here. Okay, so I got to get 3 on top to get the top to be 3, and I have a 1 and a -1. So what am I going to do to get this to be the same? Well, I'm going to need a 2 here, right? Because 2 plus a -1 gives me a +1. And I want to be careful that you don't think this is a +1. It almost looked like, because of the way I touched it, that this is a +1. Okay, so now our math is going to be adjusted. So let me fix my line. Make sure I have 3. This becomes a 3 because this is 3 already, and 3 plus 0 is 3. And then 2 plus a -1, this goes to a 1. And now we got to figure out who this element is. Okay, so who is this element? How do I know it's an element and not off that sheet? Because I don't have any zeros. So element 2 is helium. So that one is completed. Again, my numbers on top equal the totals, and the number on the totals on the bottom are equal. Okay, this is your number 30 on your homework. It says the natural current radioisotope thorium-232 has a multi-step decay that follows the pattern. So it's going to first emit an alpha, then a beta, and then alpha, 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 and so on. So we're going to start with, I'm going to get you started, but I'm not going to finish it. First thing you're going to do is you're going to predict what you think it will end with. So do that prediction. Pause and do that prediction, please, on number 30. Okay, I'm back. Or welcome back. So now we have thorium. So TH, right? Thorium TH. And we're going to look at 232 on top. Look up thorium and see that it's element 90. And first thing it does, it goes through an alpha. Okay, so alpha is 4,2He. What's left? Remember, we're thinking about the math. So 4 plus what gets me to 232? 228. And 2 plus what gets me to 90, 88? And 88 is element Ra. So you've done this one. Then you're going to take this 228, 88 Ra. And it's going to emit a beta particle, so 0, -1 beta. So then this is going to be 228, and this is going to be 89, which is AC. And then you're going to take that down and go through all the list to see what you end up with. Good luck. Please don't hesitate to reach out if you need some help.